In 1997, 3 underwater microphones heard something no animal should have been able to make. They were separated by thousands of kilometers across the Pacific. Yet the same signal reached all of them, a low sweep, roughly a minute long, powerful enough to cross an ocean. At real speed, a human ear can barely follow it. Played 16 times faster, it makes the sound that gave the mystery its name, the bloop. For years, people imagined a creature larger than a blue whale. Scientists found a better suspect: Antarctic ice breaking with enough force to shake an ocean. But that answer contains a problem. The sound was traced to one region. The ice explanation points somewhere else. No iceberg was identified, and the event was never recorded twice. This is how 1 second of audio became a solved mystery that never completely closed. Called the loudest sound ever recorded underwater. That is the audience's phrase, and it is not quite what the scientists say. The agency that recorded it, America's National Oceanic and Atmospheric Administration, NOAA, calls it more carefully one of the loudest underwater sounds ever recorded. The distinction matters because the ocean is full of louder things. An undersea volcano erupting is louder. A large earthquake is louder. The bloop was never the loudest sound the sea can make. What made it extraordinary was that it was loud and strange and did not sound like anything that was supposed to be able to be that loud. There is no official decibel figure for the bloop. Anyone who gives you one is inventing it. The loudness in this story was never measured on a dial. It was inferred, worked out backward from a single stubborn fact about how far the sound traveled. So let us go to the record and see exactly what survives. The listener was not one microphone, but a network. Across the equatorial Pacific, NOAA's Pacific Marine Environmental Laboratory, a lab in Newport, Oregon, had moored a set of autonomous hydrophones on the seabed. Instruments left alone in the dark to listen for years. They had a day job. They were there to catch undersea earthquakes, submarine volcanoes, the groan of ice, and the calls of whales along the great ridges of the Pacific floor. This array had been live in the eastern equatorial Pacific since May 1996. Behind it stood something older, SOSUS, the U.S. Navy's Cold War listening system, built to hunt submarines, which NOAA had been using for science since August 1991. The lab would keep expanding its reach, adding hydrophones in the North Atlantic by March 1999. But in 1997, the equatorial Pacific moorings were the ears that mattered. They had been listening for barely a year when the bloop arrived. The hydrophones caught the bloop because the deep ocean has a hidden highway for sound. About a kilometer down lies a layer called the SOFAR Channel, a corridor of water that traps low-frequency sound and carries it for thousands of kilometers without letting it fade. A whale or an iceberg or a mystery speaking into that channel can be heard across an ocean. And in 1997, the bloop was. Here is the fact that turns a rumble into a mystery. The bloop did not show up on one sensor. It showed up on several, and those sensors were thousands of kilometers apart. How far exactly depends on which document you read. NOAA and much of the press say sensors up to about 4,800 kilometers apart, roughly 3,000 miles. The later scientific literature says over 5,000. Both numbers trace back to NOAA. The safe way to hold it is this. The bloop was heard on instruments as far as 5,000 kilometers apart. Now, follow the logic because this is where the word loud comes from. For any sound to be detected clearly across that much ocean, the thing that made it has to be powerful. Very powerful. When NOAA compared that required power to the loudest animal we know of, the blue whale, the bloop dwarfed it. The scientist who spoke for the lab, Dr. Louder than the blue whale, the largest animal that has ever lived and the loudest, by a margin that is not small. It is a wall. Nobody measured a decibel. They measured a distance and reasoned back to a power, and the power was too big for anything alive. The triangulation pointed to a remote spot in the far South Pacific, roughly 50 degrees south, 100 degrees west, west of the southern tip of South America, a patch of open ocean with nothing there, no coastline, no island, no obvious machine or creature. Remember that point? 50 south, 100 west. Later in this story, the leading explanation will place the bloop's true source somewhere very different, much closer to Antarctica. The gap between those two places has never fully closed, and that gap is one reason the argument survives. But in 1997, all anyone had was a very loud, very strange sound, rising in pitch like something alive, coming from an empty circle of sea. First thing the analysts did was rule things out. Was it a ship? The engines of a passing vessel? No operation was ever linked to it. And again, the character was wrong. Machines do not sound like this. Fishing boats, winches, dragging cables, all suggested in the early years, none fitting a signal from that empty stretch of the Southern Ocean. Was it a quake? Or a volcano? That was the array's specialty, the thing it was built to catch. So the bloop was checked against the templates of tectonic and volcanic sound, and it did not match those cleanly either. One by one, the ordinary answers fell away. What was left was a sound that seemed organic, that came from nowhere, and that was too loud to be an animal. And into that empty space, the world poured a monster. Here is what has to be said carefully, because it is the most famous part and the least true. Dr. Fox, the NOAA scientist, made one more observation that would haunt everything after. Speaking to the press in 2002, he noted that the bloop's rising profile resembled the sound of a marine animal, too powerful to be one, but shaped eerily like a living call. The internet did the rest. Someone noticed that the bloop's origin sat not far from a set of fictional coordinates, the sunken city of R'lyeh, invented by the horror writer H.P. Lovecraft, the tomb where his sea god Cthulhu is said to sleep. The pieces fused. A colossal unknown creature, a voice from a dead city, the loudest animal that ever lived, calling from the bottom of the world. It spread the way only internet stories can. The sound a monster makes, the proof that something enormous was still hidden in the deep. For a great many people, that is the only version they have ever known. To be heard 5,000 kilometers away, the source had to be orders of magnitude louder than a blue whale, the loudest known animal on Earth. No living thing is built to do that. The sea monster is folklore the recording inspired, a myth grown around a real artifact, nothing more. But it tells you something. Scientists went a different direction, south. Through the 2000s, NOAA researchers, led by the oceanographer Dr. Robert Dziak, ran acoustic surveys in the cold seas around the Antarctic Peninsula, the Bransfield Strait, the Scotia Sea, the Drake Passage. They were listening to ice, and the ice was deafening. Icebergs, it turns out, are among the loudest voices in the ocean. As they crack, fracture, calve, and grind against the seabed, they release sudden bursts of low-frequency sound. Not the gentle groan you might imagine, but sharp, powerful broadband events. NOAA recorded thousands of them, and when they laid those iceberg recordings beside the bloop, something happened. The spectrograms, the visual fingerprints of the sound, looked alike. The same broadband shape, the same low band of energy, the same character. The signatures the scientists were pulling out of Antarctic ice looked very similar to the strangest sound the Pacific Array had ever caught. And NOAA was not the only ear on the water. Beginning in 2003, the organization that watches for secret nuclear tests, the Comprehensive Nuclear Test Ban Treaty Organization, ran its own underwater listening stations, including one off Chile's Juan Fernandez Islands. Those instruments, built for an entirely different purpose, also picked up the noise of large icebergs breaking up in the Southern Ocean. A second independent network confirming the same thing. Down there, ice is loud and it is constant. Let us be concrete about what an icequake actually looks like on the record, because the match is the whole case. When an iceberg cracks, the sound it makes is broadband, spread across many frequencies at once, with most of its energy low, roughly in the range of 10 to 500 hertz. Spectrograms of ice calving show energy sprawling from about 1 hertz up to 440, and each event is short, an impulsive burst, something like 10 to 80 seconds long. Compare that to the bloop, ultra-low frequency, high amplitude, a rising sweep lasting about a minute, the same neighborhood, the same kind of event, and crucially, ice can be loud enough. A large iceberg fracturing puts enough power into the SOFAR channel to be heard like the bloop 5,000 kilometers away. The one thing an animal could not do, ice does easily. It is simply enormous, and it is breaking. So the field had a candidate that solved the impossible part, the loudness, and matched the fingerprint. What it still needed was a demonstration. The icequakes it threw off as it cracked and collapsed were used to track the dying iceberg acoustically, in real time, following a mountain of ice by sound alone as it fell to pieces. Here was the mechanism, caught in the act. Ice, at exactly this scale, making exactly this sound, loud enough to be heard across an ocean, not a theory on paper. A live event recorded. By around 2012, NOAA had reframed the bloop accordingly. The most famous unidentified sound in the ocean was, it said, consistent with a large icequake, an iceberg fracturing or calving, or perhaps its underside gouging the seabed. A cryosism. The headline wrote itself. The bloop was an icequake, and for most of the world, that was the end of the story. But listen to the exact words, consistent with, not identified as. And that small phrase is where the argument keeps its life. Because if you look closely, the icequake answer is a class match, not a serial number. And there are threads it leaves hanging. The first is that point on the map. The bloop's original triangulation put it near 50 south, 100 west, well north of the Antarctic waters, where the icequake account says the sound was really born somewhere between the Bransfield Strait and the Ross Sea, possibly near Cape Adare. Those are not the same place. The reconciliation that the direction the sound arrived from points toward Antarctica is an inference, not a fixed iceberg on a chart. The second is that there is no single named iceberg identified as the source of the 1997 bloop. Icequake explanation says ice makes this sound. It demonstrated that ice makes this sound, but it never pinned down which piece of ice made this sound. It names the class, not the individual. The conclusion rests on the later surveys, on all those other icequakes that look like the bloop rather than on the bloop, recaught and retraced. None of this makes the icequake wrong. It is the strongest explanation by far, and probably the right one. It just means the case was closed by resemblance, not by capture. This is the kind of record we follow on Records Untold, the ones the world calls solved that quietly stay open. If that is your kind of mystery, subscribe and stay down in the deep with us. And the bloop was never alone. The same NOAA program, listening across the same years, cataloged a whole family of unidentified sounds and gave them names. Upsweep, Julia, Slow Down, Train, Whistle. Strange voices pulled from the deep, each with its own official spectrogram, each sped up so human ears could catch it. Several of them over time were also traced to ice. Julia, recorded in 1999, was attributed to a large iceberg running aground off Antarctica. The Bloop was not a singular monster after all. It was one entry in a catalog of the sounds a frozen continent makes as it breaks apart into the sea. That is the unglamorous truth the record points to. The most famous mystery sound in the ocean is, most likely, the voice of ice, vast, ordinary in the Southern Ocean, and loud beyond anything alive. There is one last thing the record insists on, and it undoes some of the romance. The bloop does not actually go bloop. At its real speed, it is not a word or a cry or a call. It is a slow, sub-audible rumble, stretched across a minute, far too low and too deep for a human ear to register at all. The sound you know, that quick, almost cartoonish bloop, exists only because the tape was sped up 16 times to make it hearable. The character we all recognize, the thing that sounds alive, is an artifact of playback. Slow it back down and the monster dissolves into a long, low groan in the dark. A record made for machines, translated into something a person could feel. So here is where the record leaves us. We know the recording is real. Noah made it. The audio and the spectrogram survive. Nobody serious disputes that a very loud, very strange sound crossed the Pacific in the summer of 1997. The mystery was never whether it happened. It was only ever what it was. We know it was almost certainly ice, an iceberg cracking or grinding somewhere in the Southern Ocean, powerful enough to be heard 5,000 kilometers away, its fingerprint matched by thousands of its cousins and proved in 2008 by a dying iceberg named A53A. And we know what we still cannot say. We cannot say which iceberg. We cannot fully close the gap between the point the sound was first traced to and the Antarctic waters the answer prefers. A sound with no witness, explained by its likeness to other sounds. A record that survives, and an argument that, quietly, does too. The hydrophone is still down there. It is still listening, and somewhere in the cold south, the ice is still breaking, still making, over and over, the loudest sound that nobody will ever be there to hear. A sound with no witness, explained by its likeness to other sounds. A record that survives, and an argument that, quietly, does too. The hydrophone is still down there. It is still listening,